So we left off on operators yesterday, and the thing we were talking about was the comparison operators. So again, the thing to remember when you're working with primitive types, you're always going to use the equals, equals, and such, all those comparison operators. But if you need to work with objects, you're either going to use the equals method, or if you need less than, greater than comparisons, you're going to use the compare to method, which is part of the comparable interface. Logical operators, you see we've got ands and we've got ors, similar way as it was in C#. You'll need to remember to use the double and the double or, because similar to how C# works, the single and the single or is instead a bitwise and an or. Okay. The bitwise operands are really good to know for certain kinds of things, specifically when you get into dealing with some sort of certain network and some file I/O stuff. If you get really low level to it, or even some Bluetooth interfaces, but is really beyond the scope of what we're going to do this semester. Beyond the scope of really what we can do here. So we won't talk too much about the bitwise operators. Precedences are the same way you expect for the most part, where times and division are a higher precedence than minus and plus. The other thing you want to pay attention to with precedence is that the ands, I believe, are higher than the ors. So just make sure you're using parentheses to get the right order that you're expecting. Actually, I'm not sure if ands or ors are the same. Looking next at strings. So strings, again, with Java, you're going to need to make sure that you always start with an uppercase S when you're creating a variable. The other thing to note there is strings are not. Again, they're not primitive types, they're always objects. And in strings, one very important thing is strings are always immutable. You can't ever change them. If you want to make a change, create a new string, you always have to create a new string, right? Which also means allocating a new array in memory, right? Because every string is an array of characters inside of it. So that comes with a cost, okay? Now we can combine strings, again, using the plus sign. I will note that when we do it with numbers, we call that addition. When we do it with strings, we call it concatenation, right? So if I was going to say, take the string 1 plus the other string 1, right? I don't get 2, right? I get the string So those are things you just want to keep clarified. If I add a number and a string, say that this was the string 1 and the number 1, I'm still going to get that concatenation as 1, 1, and so I get, instead of getting that as 2. So long as one of the two things you're adding is a string, the end result will be a string. Escape characters look similar to how they did again in C#. Start with slash, /n being for new line, /r for characters to return, /t for tab characters. Okay. If you're comparing two strings, you'll want to use that equal sign like so, the equals method. They do mention here about using the string buffer class for building strings or when you need to modify strings heavily, and that intent for that is to reduce how many allocations you have to do. So when you allocate the string buffer or string builders, which actually I would recommend, it reduces how many times you have to allocate a character array effectively. So as you're building those things up, those are definitely better. Now, in Java, there are actually two classes. There's the string buffer that they mention here. They're also a string builder. And for the most part, they behave the same way. as long as you're only working with one thread. Okay, so as long as you're working with one thread, they don't appear to have any difference. The difference here is that string buffer is designed to work with multiple threads accessing it at once, which means that it is what we call synchronized, which if you look at the documentation for string buffer, you'll see that in the first sentence or two. It says, hey, string buffer is synchronized. That's not the class you want to use most of the time. You want to use string builder 99% of the time. We won't do anything with string buffer this semester. I would definitely recommend, we won't do anything that would need string buffer this semester. I would definitely recommend using string builder exclusively instead. Okay, does that kind of make sense? Simply because that synchronization overhead does add up and does change the performance of it. It means that every time you do call any methods on it, it has to sync it up with other threads that might be using it, and that causes it potentially have to block and wait for the other threads that don't exist. So definitely use the string builder over the string buffer. But all the method names are the same. The only difference is one is synchronized and one isn't. As far as setting up arrays, there are two formats that you can potentially create an array. In Java, this is the normal form you're familiar with, int array, x, int y array. This exists because it's a kind of relic of C and C++. Don't use that one. This exists here because you traditionally could put it there, but it doesn't make sense anymore, so just always use this one. Pretend like this one doesn't exist. Array allocation, when we want to create a new array, remember, just like C#, we need to say how big is that array going to be. So I'm going to say, if I create a new array, I'm going to say, hey, I want an array of size 3. Now remember, when I create that array, I can't then go immediately add or remove elements. It's fixed length. The only way to get a new array of the only way to have a different size is we have to create a whole brand new array and copy the values over. So that's one of those things to kind of be wary of, is they don't change size. Okay. Now the way that you fill them in is then you're going to go such it like that. We can access them again by index. Java is also 0 based, so the first index is 0, 1, 2, etc. So that's how we're going to fill those in. You can also fill them in at creation time. If you know what the values are up ahead of time, it's not something that's a user input, right? So this would be definitely something I'd have to do if the size of that array is determined by a variable, then I would need to do that format. But if the size of the variable is predetermined, I know it when I write the program, I can automatically do this and fill in the values, right? So if all the values that go into the array is something that I've predetermined, that format I can use. Note that when I use this format, I don't say how big the array is, right? So here I say how big the array, it's 3 elements. I have to say how big the array is, but down here I don't say how big the array is if I'm pre-populating it with stuff. This format's also valid if it can guess the type. You can leave that part off and just have the curly braces. And the important thing there is if it can guess the type, because it can't always easily guess the type. So similar, so we can write to it using that brackets format. We can read from it. In Java, we do have jagged arrays. There are no true multi-dimensional arrays as per C#. You will remember C# had both jagged arrays and multi-dimensional, right? So if I created a multi-dimensional array in C#, I had the option of doing it like so. If I wanted a 2D, I could create it like that. that would be a 2D array, versus that would give me a jagged array. Okay. So this is the only form that exists in Java. This form does not. Okay. Now, to explain what the differences are there, does anybody remember what the differences between those two things is? Between the two-dimensional array and the jagged array?
A multi-dimensional array basically functions as a table,
Okay.
while a jagged array is an array that contains other arrays.
Okay, which is true. Both of those things are true, but both of them can also be treated as, it's true that jagged arrays is an array of arrays, but they're also both can be treated as tables. Both of them can be treated as tables.
With a jagged array, different rows can have different lengths.
It's true, right? With a rectangular array, as we would say, or a two-dimensional array, it has to, every row has the same length, right? I have to have it rectangular versus it can be staggered. Okay. The important thing though is there's a difference in how it's allocated in memory. Okay. So this two-dimensional array is still a linear array as it's laid out in memory. Okay, there's just some magic that happens. This one is literally an array of an array of arrays as it looks in memory. You had something you were going to say?
Oh yeah, I was gonna say that isn't each element in a jagged array allocated its own block of memory, whereas the multidimensional is all in one block.
Yeah. So if I say I want, so let's look at this side by side. So let's say I want an array. We're going to make it 3 by 2, and I'm going to make this one int. We're going to have a jagged array that's 3 by 2. So the way that this one lays out, you can kind of lay it out in a grid. So the first, let's see, so we have the first bit is going to be here, and then we've got, well, yeah, so 0, 1, 2, 3, and then I've got 0, 1. Okay. So the places where I'm going to put the array indexes is there. So the size of this thing in memory is, say, 8 bytes, or sorry, 8 times whatever the size of the data type, 8 hits. Okay. This length here, this horizontal length, is generally longer, as you can see. Actually, I think I've got those backwards. 3 and 2, yeah, I have those backwards. So I should do it the other way. These are the 2 and 3.
So the first number is the length of the y-axis?
Yeah, they say it different ways. Sometimes we used to talk about column major or row major. But the number I'm saying here, that's how many rows. So I'm going to say 2 is the number of rows, 3 is the number of columns. Okay. So as I'm going down to that lowest level, oftentimes it makes sense to make that a little bit longer. And we call, in this case, this would have a stride of 4. So technically, I could store this in an array that has just 6 elements. Does that make sense? So I could have that stored in an array with 6 elements. What we often do is we expand that so it's a multiple of 4, or sorry, multiple of 2, power of 2, because that results in better performance with a multi-dimensional array. Okay. The reason for that is that memory is actually laid out in a grid. Physically, it is laid out in the grid. And that means that as things lay out, there's some bottlenecks with accessing two memory locations at the same time. So for instance, what that means is I can easily access these two, if I remember right. Basically, this row and that row, I can access separate rows of this, separate columns of the same row at the same time. But the problem comes if I try to access two at the same time, I have to wait, effectively. One access has to go through before I can access the same one in the second column. So it ends up timing things a little bit better, okay? So that's the way things allocate in memory. It's just one long array. This is actually linear. It's just because the memory is rectangular, you kind of think of it in a rectangular fashion. Does that make sense? Okay. So in the actual array, this would be index 0, 1, 2, and then we skip the number 4, 5, 6, 7. So those are the actual indexes that we're really using as memory locations. Okay. So that's how that lays out with an actual two-dimensional array. With a jagged array, I'm going to have my first array, and this has one element, two elements, and this one points to another array over here. Actually, maybe I should do all of these horizontally. No, I'll go ahead and keep that structure that I have. So 0, 1, that one points to 0, 1, 2. So we have three different, if I allocate this way, I've got three different arrays, three different places in memory. So I've got my outer array, which is this two, that's the outer array, and that's an array of arrays. So this array points here, that's my first row, that's my second row. Because that's an array of arrays, you see in this structure, every row has to be the same size. In this one, it could easily be, I can easily add another number in there. These don't have to be the same. They're not constrained because of memory layout.
So effectively, the first array works as a pointer to a different array. Each index in that first array works as a pointer.
Yeah, yeah, exactly. Everyone here, this number here, there's a memory address to that.
Mm-hmm.
That other array. Because remember, arrays are objects, right? So this object here, this is actually that type. If I were to look at the data type of this is just another array of integers, right? So that whole type is int3. This would be int3. This, now that I've grown it, would be, if I replaced it with something larger, would be int4.
So what does the 3 actually mean then, if you can have multiple sizes on the...
So when I initially create it, it will be rectangular. When I initially create this jagged array, it will go ahead and create all of those subarrays in a rectangular form.
But you can also reinitialize each of the elements in that first array.
I can replace them.
Yeah, okay.
The other thing I can do, if I remember right, you can say when you're creating jagged arrays in Java, I can say new int, and I could say 2, but leave the other one undefined. If I left the other one with just empty brackets, all of those would be null instead of it creating the arrays for me. Does that make sense?
Mm-hmm.
So it would create this first layer, as nulls. Okay. The reason that's important is A, jagged arrays, they don't have to be rectangular, right? So these implicitly have to be rectangular, and I'm implicitly kind of wasting some space with that stride. Okay. I don't waste space over here, and they can be of varying lengths. In fact, I can't even force that it has to be rectangular once it's been created. But this usually has a higher cost as I iterate over the array. Okay, because there are different places in memory, and because as I iterate over it, it has to jump. Right, so it's jumping from 1 to 3 different places in memory, and that grows up. The more rows you have, that has a cost. So as far as iterating through the whole array, this one is slower than that one. So that's why this one exists, is because this one is the fastest one to iterate over. Does that make sense? This is an optimization on iterating over the entire array. That's the big reason why that exists. Okay. So in Java, if you ever need this, basically you build it yourself with a linear array, and then you wrap a class around it and make it look as if it's two-dimensional. Okay. We also have in Java, we have lists and array list. One thing to know with lists, the way that things are named in Java is quite different than it is in C#. Okay, so in Java, in C#, you may remember that there's a convention for naming interfaces. Do you remember what that is?
Started with a capital I.
Started with a capital I. So in C#, if you start with a capital I, it's an interface. Well, that convention was never there in Java, right? Because Java was the first one to come up with this idea of interfaces. So it's like, okay, we'll just call them the same thing as classes. So there is no special convention for naming interfaces. Okay, they don't start with an I, which can lead to some gotchas if you don't realize that something is an interface instead of a class. So if we're looking at the hierarchies of these things, so in C#, I have iList, and then from that I have list. Right, so the list class implements the iList interface. Right. As far as what we're looking at in Java, we have the list interface. Interface is just called list, not iList. Okay, so the actual version of that is array list. Okay, so array list is the implementation of the list interface that is backed by an array. Okay, and there's also something in there called vector, which you may see in some older tutorials people using, which also implements the list interface. Vector is synchronized, the synchronized version of it. So again, just like with string buffer versus string builder, this is the one we'll use instead, because we don't need the synchronization typically. Okay, that kind of exists as a callback, a fallback from C++, where our structure was called vector. So as you're working with lists, you're going to actually call it array list, not list. If you do have a list data type there, recognize that you're working with the interface, not with the class, which means I can say new array list, but I can't say new list. That makes sense? I can say new array list, I can't say new list, but I could have that variable type be list. So as we're having these things, I could say list A is equal to new array list. Okay. Now you will notice in this code example that they have here, notice that they haven't put a bracket that less than, greater than for the data type. Notice that that's missing there. Okay. So in Java, if you leave that out, it typically defaults to object. So this is an array list of objects instead of being an array list of specifically the type that you wanted. Does that make sense? That's typically not what you want, because if you follow through that and don't type it, it's just a list of objects. Well, then you can put any sorts of objects you want in there. I can put numbers, strings, employees, and everything under the sun in that same list. It's probably not what I want. I want to type it so that only certain things can get in there. It also means when you pull values out using the get method, you then have to cast it back and guess what it should be.
So how come you can't just do the brackets instead of?
What do you mean the brackets?
You can't.
You
Like,
can't put in there.
In C# you can just say like.
You can.
You can.
You can't.
Yeah,
that's just.
I can say array list string, and I would recommend that you do. That's later in this book. And talk about generics here. But yes, I would recommend anytime you're using lists or array lists, use the generic form. Does that make sense? Yes, you can. It does exist. They're just not using it right now. So as far as adding things in, when you're working with lists, this works whether or not it's generic or not. Add things, set to replace a value that's there. So this is going to replace the value that's in the first spot, the first element, with below. Okay. Now, if you don't have a 0, if this list is empty, that's going to throw an exception. Okay. You can only do a set if that index already exists, and then you can also remove it. So that's quite a bit more flexible than just working with an array, right? Where it's just a fixed size. Okay. So add, set, remove, those are the 3 methods you want to know there, and get to go grab one. Do you note in here, how we're doing get 0? Like I mentioned previously, there is no operator overloading in Java, so that means I can't do brackets 0. Okay. Yeah, you can't do brackets 0. That's supported by, in C#, it's supported something called indexers, where you can write your own indexers to implement that bracket syntax. Java does not have that. So anytime you're working with a list or a collection and you want to get an element out, know that it's going to be a method, not brackets. You only get to use brackets with actual arrays. All the other collections use methods. Conditionals, I'm probably just going to skip out. I don't need to say too much here because nothing's new. It's if else and else if. They work exactly like they do in C#. Switch is worth talking a little bit about. So one of the things that you need to know about switch, again going back to history, the switch in Java works like the one in C++. It doesn't work like the one in C#. Okay, so one of the things that C++ allowed you to do is leave off the break statements. Okay, and if you left off the break statements, it would what we call fall through, right? So if I have this switch statement and I erase these break statements here, if I get y is 0, it's going to print it's going to print 0 is 0, 0 is 1, and 0 is something else. If I were to eliminate those. If I was just to eliminate the first one, it would say 0 is 0, 0 is 1. Because we get to that break and then get out of the switch. So it falls down until it finds the first break and goes out. Does that make sense? In C#, you're forced to end every case with a break statement. Java does not force you to do that. The other thing that you can do, this is not different between C and C#, between Java and C#, but worth noting. So I could also put in there case 0, case 1. Something like that is valid, and that means that if I get either 0 or 1, I go to do that the lines of code that are in those combined things. So I can combine cases like that and have them do the same code. Does that make sense? But if I don't include that break, then it will go on to the next clause from there.
So that's basically the same as an OR.
What do you mean the same as an OR?
Like
This is.
Yeah.
This is the same as an OR. Yeah. Yeah. So if it's either 1 or 0, it'll go there. I can also find things like, let's say I wanted the default case to go also in there. I could do something like that where I have my default case combined. So default 0 or 1, all that would go there. The only thing that would go to this case would be 2.
If you want the default to do the same thing on other cases, wouldn't you just exclude those cases?
As in that?
Yeah.
Yeah, you could. And sometimes it makes sense to put default and some other things, just for clarity.
Yeah.
Sometimes it's a way of documenting and saying, I wanted it to do this for 0, 1,
Okay.
and anything else I didn't think of.
Functionally, though, it's identical.
Functionally, it's identical. Yeah. But just know that that default doesn't have to be at the end.
Right.
It can be anywhere. You just always want to include a default, and that's a way of saying, I thought about what would happen. What did I want to have happen if it wasn't something I expected, right? So I expected these values, but if it was something else, throw an exception or log an error, whatever it may be. Any further questions on that switch? Yeah, that's the biggest gotcha, is that if you leave out the breaks in C#, it will go ahead and give you a compiler error and won't let your program run. Versus if you leave them out in Java, it'll say, okay, that's fine. I'll just run multiple cases. There are rare cases where that's what you might want to do. The only cases I've really seen where that applies mostly is in console applications. It's very rare that that fall through is helpful with GUI applications. Although it can occasionally happen. This is relatively new. This did not used to be in Java, but you can now switch on strings. Important thing to know, and this is overall, anytime you're switching on strings, doesn't matter the language. If you're switching on the strings, the case does matter. Okay, so this will switch on lowercase apple. It will not switch on uppercase apple. Okay, the reason that works is because of this actually gets compiled. The reason it works that way is this compiles down to a hash map. So these are actually hash codes, and the hash code's different based on the case of the character. Okay, ternary operators there works the same. So you remember you're going to have a Boolean expression, and then a question mark, and then if it's true, this value; if it's not, that value. That can be quite useful, especially as you get into things like streams and functional programming. As far as loops go, we looked at one of those yesterday. We looked at the do-while loop. There is the while loop. There is the do-while loop. There's the for loop. For loop is going to be the one that you use the most. And just a reminder, every while loop can be turned into a for loop. Do while is slightly different because of that, at least one. But technically every loop can be written as a for loop. Doesn't matter what it is, it can be written as a for loop. The thing that will be probably the biggest gotcha is that for each doesn't work the same way, it is not written the same way between C# and Java. So in C#, we write it as for each, and then there's that for each variable in, right? We don't write the keyword in, we don't write the keyword for. In Java, we just write for. At the beginning, it's still for, it's not for each, but there's a colon here. So it can be a little harder to spot. It can be quite a bit harder to spot for each versus a for. Typically, especially when this was introduced, this was called the enhanced for loop. Because, yes, it's a for each loop, but the for each keyword is not there. So we typically call it the enhanced for loop. But otherwise, it works the same way as the for each loop. Okay. Break and continue. Remember, if I put break in a loop, I'm saying that at this point, I want to finish running the loop. I'm going to stop early. Continue says skip the rest of the code in this iteration, go on to the next iteration. So if I'm in a for loop, the continue means that it's going to go on to this increment part, check the onto the increment part, check the condition, and then proceed if possible. Okay, the continue does not skip the increment, which is one thing that a lot of people is often, to be honest, an interview question. It's one of those things you need to know. There's also in Java, they added something in, I think it was Java 5, it's called labeled blocks. And those can be used together with, including here, it kind of shows if you have multiple loops that are nested inside of each other, you can use a labeled break or a labeled continue to get out of more than one layer of loops. So if you ever have, hey, there's 3 for loops, I need to get out of all 3 of them, you can use a labeled break to break out of 3 loops instead of just breaking out with the closest one, which is what break does. It only breaks out of the loop that is written inside. As far as defining methods go, again, it's going to be return type and then the name of the method. You typically want to start that with an access modifier. Your method should always start with an access modifier. Typically, that's going to be public or private. We'll get to access modifiers in a minute, but the default access modifier is not private, contrary to a lot of people's belief. It's not actually private by default. As far as calling methods, in order to call a method, you have to have an object. So first you need, if we want to use this myApp object, we need to say new myApp, save it to a variable, and then we're going to call myPrint on that variable. Okay. Method parameters, similar to how C# works, I can add as many as I want, and they're going to be then passed in as arguments in the order that I specify them. Few things to know on method parameters. There are no ref parameters, there are no out parameters. Those don't exist. I think that not too long ago, defaults were added, so you can add in defaults. So I could, for instance, in here say that by default this is empty string or 5 or whatever I want to start it as. So I can give it default values. I do believe they added those. I'm not entirely sure about that, but I seem to remember hearing about them getting added to the Java language. But one thing that isn't there for sure is the ability to pass arguments by name. That doesn't exist. So you still can't pass it by name, as you might have seen last semester. Method overloading, we can create a bunch of different methods with different parameters. You'll see that a lot in several different places, including print line has a version that takes nearly every kind of data type that you can imagine. For objects that are not strings, so say arrays or anything else, what that's going to do is it's going to call toString on that object, and that's what it's going to output. As far as passing arguments go, is there a note that I had? Oh, okay. In Java, as I said, there's no ref and out parameters, so everything in Java is passed by value. Okay. Now that can get a little tricky in terms of terminology, because remember I have primitive types and reference types. Okay. Primitive types are passed by value. Reference types are also passed by value. Okay. But when I mean passed by value, what do I mean? When I'm passing a primitive, let's say I have int x, and then I'm calling a function. Let me declare foo first. So void foo takes an integer, and I'm going to call that one y. So let's just say inside of there, all I'm doing is I'm going to increment y. Okay. So if I call, let's say I have int x is equal to 5, and I call foo with x, okay? So I'm passing x in here by value, which means they're ending up in two different places in memory, right? So x is in one place in memory. I make a copy of that value 5 and put it somewhere else in memory. So this y and this x are different places in memory. Make sense? They're copies. Okay. So when I come down here, if I go to print x, what am I going to get? Am I going to get 5 or 6? Show of hands, who thinks I'm going to get 6? Essen.
I got it, you all.
Okay, so we've got a few hands for 6. Essen. Okay. What am I going to get, 5 or 6? Okay. Okay, so go for it. So we've got some guesses for 6. How many guesses for 5?
Change my answer to 5.
Okay, so I'm going to go by the people who are undecided. Brandon. Huh? Okay. I said int x is equal to 5. And I said call foo, passing in x. Then let's print x. Okay, so foo is just taking in that number, doing plus plus on it, incrementing. Right? It's a good question, but no, the return doesn't matter. Whether I said return or not, it actually won't matter here.
It won't increment because it's in that block. So it's not actually returning anything, not method.
I was thinking that if you passing a primitive, doesn't it pass it by value rather than reference?
Yeah, so this passive by value. That's what's important. Because this is a copy, looking at memory, x, I've got 5 here, I've got y over here. Initially it's got 5 in there, that's what's got 6. These are two different places in memory. So when I get down here, I'm going to still have 5. Y will be 6, but X will be 5.
So if you, but to play, not even play devil's advocate, but if you were to like just have a type in return and set X to foo for 5, then X would then be 6.
Well, so 2 things there. So let's say I make this return, I return Y, okay? So in this case, nothing changes. Nothing's changed.
Right.
Because I've not done anything with the return, right?
Hmm.
I can return all I want, that doesn't matter unless I actually say, take this value that's over in this other place in memory and overwrite X. You had a hand up, Alex?
I was wondering if, like, remember in C# we could force it to pass by reference. Can you do that in Java?
No, that's what I was saying. You cannot. Remember, the syntax in C# would be int ref y.
Yeah.
I can't do that. That's not supported. And the reason that's not supported is, again, going back to this whole debate of all these problems that they were in C++. That was a very, very big point of headache in C++ was pass by reference. Got a lot of people confused. And even the professional C++ stuff that I did, still people were very much confused about that point. So you were talking about if I change this, if I say is X is equal to foo X, yes, so then I'll have 6 here. Then I'll have 6 here. Now, little gotcha.
Yeah.
Does that still work? Do I still get 6
No.
here, or is it 5?
Yeah,
It's on a
it
new
would
line,
still be
right?
5.
Huh?
So it's on a new line, so that means we're implemented.
Well, it's post.
It's post. So remember, if I write this as plus plus, if I write it pre, then effectively it happens before the line. So I say plus plus y, return y, right? But if I say post, it happens in the other order. So I return y, and then I increment it.
But by the time it increments, y doesn't exist anymore, right?
But it still does the increment.
Yeah.
It still does the increment. Sorry, that would be. So if I do it as a post there, yeah, the increment happens after the line. So I still get 5 back here.
Well, that one didn't run because it's confirmed, right?
Huh?
I said that the y plus plus would run because the method confirmed.
I mean,
But would it? So if the compiler wasn't doing any sort of optimization, it was just running the code that you told it to run, it would be doing it then. But since the compiler more than likely will figure out, oh, that's useless work I don't need to do, it probably won't do that work. So when you actually look at building it and making it production ready, it will probably take that step out. Yes. However, if you're running unoptimized, it may still run that code. Depends on what the VM decides to do, actually, to some sense. Depends on what the compiler and what the VM decides to do. It may do that increment, it may not do that increment.
If I simply refer to increment, y would still need to have to exist in memory, right?
Which it still, yes.
Okay.
Which it still does for a brief period. It would still exist for long enough. What that means at the lowest level is I basically copy y over to someplace, change it, and the thing that goes back is actually that copy, basically. Y and the thing I return are 2 different places in memory. So that's those are important pieces to remember. So that's with primitives, right? So anytime I have primitives, I'm making a copy. So any changes I make in this function, under the assumption that I'm not setting it back here, right? Whatever I do up here, X doesn't change because they're in two different places, right? Now, if I'm dealing with a reference type, so let's say I change this and we're dealing with a reference type instead. So I'm going to take an array of integers instead of a single integer. And in here I say y0 is equal to 7. Let's also have an array down here. X is equal to 1, 2, 3. Okay. If I do this, make these things bigger. And you want to move a little bit closer so you can see better. Okay. You want to move a little bit closer so you can see better. Because my writing is a little bit small. So if I do this, okay. Okay. So I'm passing X to here, and then I make a change at what's there, come back, I'm going to find out that it has actually changed. So if I think about this, remember X is kind of a pointer to where it is in memory, right? So the actual data for the array lives somewhere else. So that data is 1, 2, 3, and I have a pointer to it that lives in X, right? So let's say this array, this location where it occurs is 72. I'm going to have 72 here. What I do when I pass this array to a method, I don't make an entire copy of the array, right? Because that would be pretty expensive, right? Let's say this array has 1,000,000 elements in it. I call a function, now I have to make a copy of 1,000,000 elements, right? That would be really expensive. So I just copy the number. I just copy the 72, which now means both of these, X and Y, are both pointing at the same location in memory, right? So I've copied the reference by value, but I still have them pointing to the same place. So if I do this, X is equal to Y0 is equal to that, that's going to be 7. I'm going to replace this place in memory with a 7, and that's what you're going to see printed out. Okay. So everything's passed by value, but that doesn't mean that you're safe in the sense that everything is copied.
So why is there that discrepancy between reference types and primitive types?
Reference types and primitive types.
Like why is there a difference there?
Well, remember the value. So let's say I've got an integer. It's just a number, right? The reference is also a number, right? 72, right? The reference is the number. I'm doing the same thing. As long as you think of the reference as this and not that, they are the same thing.
Right.
There is no discrepancy.
Well, let me just rephrase. Like, so why doesn't it function this way for integers? Or it's like I don't. Why does why? Like, what's the benefit of that?
So it comes down to performance, really.
Oh, okay.
The reason that it's done that way. So copying a single integer, copying a single value is easy, is cheap, and it's usually worth the cost in terms of safety. However, copying an entire array can be pretty expensive. So you don't want to do that by default. So basically, if you want to copy an array, you have to do it manually, right? You have to make a copy of the array and pass it in, or the function has to make that copy and operate it. That's what it comes down to, is because if we didn't do it this way, their programs would be slow. Believe it or not, this is the same way it works in C#. If you don't use ref or out parameters, this is the same way it works. You pass an array, you're passing a copy of the reference. Okay. It also means, remember that because these both have a reference, remember we talked about garbage collection? Garbage collection, an object gets garbage collected once nothing has a variable that points to it, right? So in order for this array to get garbage collected, both of these two variables have to lose it. They both have to go to null or go out of scope. Okay. As long as either of them holds a reference to it, it has to be kept in memory. Which means if I'm calling function, and I've got a call stack like this array is still being held up. Does that make sense? You kind of see what's happening there? And the same thing can happen if you're passing around a string builder, because a string builder is just a wrapper around a character array. Or if you're passing around a list, an array list is a wrapper around an array. So if I pass a list into this method and change the first index, I'm going to see the same behavior where that list is modified and I see it down here.
So passing a string is by reference in Java?
Yes, passing a string is by reference no, it's still by value. You're still copying the value. So let's say, just like this is, let's say instead that was strings. So I've got my X, I've got my Y. This points to some string here, call it hello. Right? Say this is 53. Okay, I pass it to foo, it's still going to be 53. But it will be a different place in memory, right? If I'm passing by reference, these two are the same place in memory.
Yeah.
If I'm passing by value, they're two different places.
Okay.
Okay, so what that means is, yes, I'll still see hello here. If I had a way to change that string, it would change in both places, right? Which is one of the reasons why strings are immutable. You can't change them in Java.
Unless you initialize another one.
They are immutable. I can only make a new, if I want to make hello world, I have to make a new string. I can't change this string right here.
Okay, you can probably make a new string and have it be different depending on the context of
Right.
what you pass.
So let's say I change this up, and let's actually write this as a, we change this to be strings. So string Y, and let's say I do Y is equal to hello world, or just world. Right. So in this case, right, so I passed the word hello.
Yeah.
I've changed Y to world, which means that it's going to get pointed somewhere else, which is where world lives.
And
So now it's no longer pointing at that place.
yeah, I understand that now.
Right. So if I change what's here, I'm putting a new reference into there, which means I don't affect the method that called me. Does that make sense?
So the string concatenation effectively create a new
The
string.
same way.
Yeah.
So if I would say plus equals here, I would have hello world over here.
Mhm.
I would have hello and I would have hello
So now it's basically passing by value, but not really.
world. Yeah.
Okay.
Yeah. That's the point. So it's technically, from a technical standpoint, it's always passed by value.
Yeah.
It's always passed by value. But when we're passing a reference, we're passing the reference by value.
So what I'm getting is that mean that's just well yes, but actually no.
So if I was working with, to go back to the case of the array question, if I were to do a similar thing with the arrays, void foo, and I take int array y, and I say, sorry, int array. Then I say y is equal to new int array 3. This y is now in another place in memory than x was. That makes sense? By a similar token of what happened here with the concatenation, or setting it to something else, if I say equals, that puts it in y into another place in memory. This means that y is now in another place in memory and won't affect x. Does that make sense? That's the difference with pass by value or pass by reference. If I was passing by reference, this would work and you would see this back in the original method.
Mm-hmm.
That's the difference. This is the case. If you change, I say this equals, but not if I call a method on the object.
Yeah.
Effectively. Any methods I call on the object, I'm not changing the actual object. Okay. So that's kind of where we're at. The reason why it's a big discussion and why there's as much confusion and things like that as there is with the terminology is because, let's go back to C#, there were 4 different ways to write this. So not C#, well, C# there is as well. It looks different, but back in the C++ days, we had 4 different ways to write this. We could say int x, this would pass the value by value, right? We're passing the number by value. Or I could also put in a little ampersand here, or in C# put the ref word, and this would pass the value by reference. Okay. Now that means things like what I did with plus plus x, those things come back, right? If I pass the integer by reference, then if I change x in that function, it changes in the method that called it. Okay. 9 times out of 10, that's a very dangerous thing to do because you don't know what this function is going to do, and now that often means you're dependent on the implementation details of that function. So that's what we meant by pass by reference. And then we also had the ability to pass pointers, right? So I could pass a pointer by value, or I could pass a pointer by reference, right? So in Java, we really only have 2 options. We have the pass the value by value, or pass the pointer by value. It just gets confusing because we've called these things pointers reference, right? A reference and a pointer are basically the same thing for the most part. Okay. I hope I haven't confused the issue too much because it's a pretty deep rabbit hole once you get into pass by value, pass by reference. And I remember when I was in college that it was something that I had a disagreement with my professors because I've actually seen different Java textbooks say that Java is passed by value, and some of it said passed by reference. It's one of those things that is kind of hard to get a hold of. But that's the thing to understand is how it behaves, right? And the biggest thing you need to understand is that those references, they're pointers, right? So enough talking about methods and pass by reference. Let's talk about classes. So if I want to define a class, I start with the class keyword, name the class. I also typically want to say an access modifier on there, so I'm going to always say public class. Okay. The rule for your files is if you're creating a class called a file called main, there has to be a class in there called that's main, that's also called main, and it really needs to be marked public. Otherwise, you'll get a compiler error, typically. Okay. With Java, you can put more than one class in a file. The rule is only one of them, though. The one that has the name of the file can be public, and all the rest can't be public. They have to be what we call package private, which we'll get to in a minute. If I want to create an object, I'm going to use the new keyword. So I'm going to say new blah. If I want to create a new my new rectangle class, I'm going to say new rectangle. Just like C#, I'm going to declare member variables or fields here, and then I'm also going to declare methods. Okay. Your member variables should typically be private, and your method should typically be public. Unless it's sort of an implementation sort of method that's only called by other methods. Unless it's an implementation or it's like a utility method sort of thing that's only called by other methods in the class. So sometimes your methods get long enough that you have to break them up into smaller methods, at which point you make those smaller methods private, right? Because they're only used by that class. They're not used by the rest of the world. So public methods are ones that are meant to be used by other classes. Private are only meant for yourself. We can access the fields and the methods just by having the object and then saying dot get area dot x dot y. You can see that. There are, of note, there are fields. There are methods in Java. Is there something missing? Properties. There are no properties. Properties don't exist. So if we want to have fields, we have to write getters and setters, and we actually have to write them as methods. There are no properties, I'm sad to say, in Java. That's an interesting discussion in itself, because when C# came out, that's probably the biggest thing that caused people to switch over to C# was properties. And because C# was the first language to come up with that idea of properties, and it has made things so much easier. Enough to make people want to switch languages. This keyword, we can use that in constructors, and this often happens. You'll see this in a lot of Java code where they'll have variables. Let's say here they're x and y. Your parameters are also x and y, so therefore they're shadowing, right? The only ones you see are the parameters because they have the same name. So if I want to get to the actual member variables, I have to use the keyword this. So I say this.x equals x. So this.x is the member variable, and x is the parameter. So you'll see a lot of this sort of styling when you're looking at Java code. The other way to write this, and the way I would recommend, the way I do these things, is I do underscore x and underscore y up here. So then this ends up being underscore x equals x, underscore y equals y. That's how I typically name my variables. I start my member variables with an underscore. That way I can tell between what's a member variable and what's a parameter.
So this is referring to the top.
This is referring to those member variables up here. Yeah. So this dot x refers to this one, this dot y refers to that, but this x and y here refer to those x and y. You can also have a bunch of constructors. You can have what we call constructor overloading. So you have one constructor that takes a certain number of parameters, another constructor that takes a number of parameters. You often see this where there's maybe some values that aren't always used, right? So maybe you have some things that you might want to specify when you construct an object, but you have a reasonable default. So in this case, their rectangle, they're defaulting to a rectangle that is 20 by 10 by 20. If you don't tell it what the dimensions of it, we'll default it to 10 by 20. If you tell me one dimension, then I'm going to assume it's a square of size A. And then if you tell me both of them, I'll take that A and B. Okay. This works. It's valid code. I strongly advise you to be very careful with overloading constructors, because it can very, very quickly get confusing. And you're also looking at, okay, now I have 3 constructors. I have 3 different places I could have a bug, right? So you potentially could have something not working. Now, you can simplify this a little bit using something they call constructor chaining, where instead of writing the code again and again and again, you can tell this constructor calls the other constructor. So in this case, the constructor that takes no arguments is calling the constructor that takes 2 and passing in 10 and 20. And this one that only takes 1 is passing in this third constructor with A for both. Does that make sense?
So is that like the same thing as like the base in C#?
No. So base, remember, refers to the base class or the super class. Okay. This refers to the actual class that you're writing. Okay. I can use the word super. So in C# they use the word base for the base class. In C# in Java I use the word super. If I wrote super 1020, I'm calling the super constructor and passing in 1020. I'm not calling this constructor here. Now, what you'll typically see if this class had a base class, you would see this, and then in this method is where I would call super. That third one is where I would call the super constructor if I needed to. I wouldn't call the super constructor in the other 2. So effectively what this means is these 2 constructors here are just a shorthand for the third. Does that make sense? That's what I'm doing. As I'm saying, those 2 are just a shorthand for the other 2. So if you see that, then replace that. But again, this can very quickly get confusing. So ideally, your classes should really only have 1 constructor, as much as you can make, as much as you can make that happen. You can also initialize some of the field values like this. Int x is equal to 10 and int y is equal to 20. Those initializations, though, happen before your constructors run. Okay, so any code you put there like that happens before your constructors run, which is worth knowing. Okay. If we don't declare a constructor, we still get what's called a default constructor. The default constructor always takes no parameters and will initialize all your variables either to 0 or to the initial values that you set like so. Okay, so if you haven't told them what to initialize, it's going to get initialized to 0. We can also set any references we have to null, meaning that that reference doesn't point to anything, right? And if I want to check if it's null, I can say, does this s equal null? Or I can say, does not equal null. Things like that. As I said earlier, if I construct a myapp here, you see there's no constructor. So when I can say new myapp, I'm going to end up with x is 0. Okay, everything gets initialized to 0.
If you create a constructor that has no parameters,
Okay.
Is it still considered a default constructor?
I would still call it a default constructor. That's kind of one of those things where there's two different terms. A default constructor can be the one that's automatically generated, or it can be a constructor that takes no arguments. Both of those two things are referred to as default constructors, depending on who you ask. And then garbage collection is one thing to know about. Typically what's going to happen is they're going to get garbage collected when they go out of scope. When all your local variables they're referring to them lose a reference to them. But if you need to force that to happen sooner, you can set it to null. So if you have some really big array, a really big object that you know you want to get garbage collected as soon as possible, set it to null, and that will encourage to do it sooner. That doesn't mean that this object gets immediately deleted the second you set it to null. That means it gets marked as ready to be deleted, and it will get deleted at some later time when it's time to delete things. It just means that it'll happen sooner.
That's the form of activation.
Yes. Yeah. So setting things to null can mean that you get better performance. However, that's only worth doing for large objects. Okay. It doesn't really save much to do that for small things. Okay. So if you have an array that's is very large, such as image data, if you have all the image data for an image, you probably want to set that to null to make sure that that thing gets cleaned up. If you're really, really curious about learning more about garbage collection, the system that Java uses, most JVMs use nowadays, is called a generational sort of system. And it's definitely worth reading up on it. In fact, C# uses the same sort of system. There are some differences between how they garbage collect, but they're both generational systems. So if you're at all curious about how that works under the hood, that's what I would read up on. Okay. So static. Static, similar to what you've seen before. If I mark a field static, that means there's only one copy of it, only one place stored in memory, and that is accessible without having an object of that type. It also, however, means, let's say I have this static pi here, that memory can never be garbage collected. Anything you put in a static variable will never be garbage collected. Once it's there permanent. And that has a really big impact because let's say you make a list that's a static variable, right? Well, as I keep adding things to that memory never gets thrown away, okay? And it's not unusual to see lists that stick around for a long time. For instance, if you think about hooking up an event listener, right? Typically there's a list of event listeners, right? You say this button is listening for click events. Well, so there's a list of quick listeners, right? Well, if you're not careful, these kind of things can blow up. So anyway, so static that you can do, just be very, 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 very cautious of using that. And especially I would warn you in Android. So Android's got some interesting things to how it works with processes and with apps. So for instance, you may have an app running and it has 3 copies of itself running. Can it happen? Well, each of those 3 copies has a different copy of the memory. So if you have a static variable, there's still a copy of that in all 3 versions of that. And they're different, they're separate. So a lot of the tricks like singleton or what they're going to show here in a minute with concatenate, with keeping track of how many instances there is of something, doesn't typically work in Android at all for a lot of reasons.
So should you only use like static variables for like constants?
Only for constants. As far as Android's concerned, that's the only acceptable use of a static variable is for a constant. In no other circumstance you should use it for anything else.
You cannot. Sorry, can you override in a subclass a static field?
No, nothing static can be overridden because remember it's bound to the class,
Right.
not the instance, right?
Okay, yeah.
So inheritance is always based on that inheritance hierarchy, right? So statics are never overridden. They can be hidden, right? So if I have one class with the variable pi, a constant pi, and another class that's a subclass with a constant pi, there will be both pi's, and they will be both called pi. But if I say class A dot pi, I'll get one constant. If I do class B dot pi, I'll get another constant.
So like in that case, if I want, I would call it super.pi or whatever if I wanted to get the parent's version of that static field.
No, you would call class A dot pi or class B dot pi.
Oh, right, because it's not, yeah,
Super,
okay,
super
right.
doesn't work for accessing static.
Right. I got you.
So that's one of those things you need to know. They are not inherited, and you don't want to use them because when we're working with Android, you're going to get multiple copies of memory because they can end up as separate processes. Every process gets its own set of memory, which includes potentially things that you're running in the background can potentially have a different copy of memory than the things that the app that's in users, which can be an issue for things like notifications. The other thing that often happens with Android's pretty smart on making sure there's enough memory available for every app on your phone or your tablet, and throwing away memory that's not in use. So what that means is there's an app that's running, but you're not in it, well, it's eventually going to throw away that memory. Okay? So eventually it's going to throw that away, and then when you come back to that app or you turn your phone back on, this can even happen if your phone just goes to sleep, it may throw away all your memory for your app and then recreate it when you come back. So things like where is it?
Is that saving it to disk then?
It will save it to disk only if you tell it to save it to the disk. We'll get to that when we talk about Android. But we have to actually tell it to what we want it to save, because otherwise we'll lose the user's data.
Yeah.
Yeah, we have to be pretty explicit about saving things.
I know Windows has an option.
So,
Can
for instance, this right here, static field, they show you dummy, and they say anytime you call dummy, increment count. So then in theory, count will keep track of how many times dummy is counted. This does not work on Android 9 times out of 10. Because if the device goes to sleep, that number will get reset to 0, or your app gets deleted, whatever. If it stops running, that'll go to 0. If you have 2 copies of the app running, one will be one number and one will be another. So as far as static variables go in Android, really, I can't stress this enough, don't use them. I will see you tomorrow.
So wait, personally,